Okay, welcome everybody. This is the Data Facades Community Group monthly meeting. Here we are, a few more participants joining now. I'm really happy today because we have Triply presenting and showing us their work on FacadeX. This is a good opportunity for us to learn what's going on the adoption side of this approach, and also try to maybe later have a discussion on what kind of specifications it would be useful to produce, and how to address a few things in the way we present data facades as an approach for the industry. So I think maybe when I will pass the lead to our guests, and maybe you want to introduce yourself and tell us a bit more about your work.
Yeah, thanks. Let's first do a quick intro. I'm Laurens Rietveld, co-founder of Triply, together with Wouter Beek. And
I am Martin. I work as a software developer at Triply and mostly develop the Sparkle engine.
Yeah. I think I'll probably do the first half of the presentation and then Martin takes over. Let me go over the slides. Interrupt me whenever you have questions, obviously.
Can you see the screen?
Yes, we can.
First, a bit of about us section. For Triply, main product is Triply, which is a cloud database, linked data database. So a bit of context, this slide is borrowed from the sales section. I'm personally not in the sales department, so I'll try to wing it. I'll cherry pick what I want to talk about here. I think what's most interesting for me in this slide is that we're currently the market leader in linked data and triple SOAR products, specifically in the Netherlands, in highly regulated industries. So we're involved in the Ministry of Finance, how do you say cluster in English?
Land Measuring Agency.
Yeah, that's a good one indeed. The Free University, also the Flemish government institutes. So government, we have quite a big presence there. And our ambition is to be a top 5 EU player in linked data and triple source, as well as a global self-service provider in the context of databases, linked data databases. So that's a bit about us. The contents of this section, we're going to talk about how we use FacadeX and why we see value in FacadeX. And before we talk about that, I would first like to talk about typical ETLs and the problems that we and customers of us experience when it comes to ETLs. So typically, ETLs are, they're mechanisms for extracting, transforming, and loading linked data, getting data from a source system, whether it's SQL or CSV or XML, into linked data in the context of linked data databases. And typically, there are quite a few knowledge requirements that you need to get from your source data into linked data. We have Triply ETL, for instance, as a product that we publish, that customers of ours uses to indeed get from their source data into linked data. Current knowledge requirements there are Git, because this is a Git configuration, GitLab CI, because you want to periodically schedule things to be transformed into linked data. TypeScript, that's the configuration language. You need to know about the ETL configuration interface. You need to know about linked data. All of these knowledge requirements add up, making it not very suitable for a regular data scientist. It's also a product separate from TriplyDB. So we, as you see here, all of these requirements make it difficult for us to maintain a product like this. So this is the current situation for a typical ETL. You have an extract part, you have a transform part with often custom codes, and a load part. And a load part, that's the TripDB part. And most of this lives outside of TripDB. Where we want to go towards is having an EOT approach, not extract, transform, load, but first extract and load, and then apply the transformations using RDF standards and such, and all within TripDB, so that all of these knowledge requirements that you need, Git, GitLab, CI, etc., can be replaced with, well, knowing TripDB, knowing RDF standards, having a focus on standards, etc., etc. So again, ELT, what we see here is very different than the ETL approach. First, focus on extracting the data using, so this is mostly on a protocol level, getting something via HTTP, SSL, FTP, etc. Then loading the data, importing the data into TripDB as quickly as possible. And then transforming the data, post-processing it when needed, going from linked data to linked data with Sparkle queries or something similar. So as you see here, we'll get to that later, the load part, importing data of any civilization into TripDB, that's where FacadeX plays a very big role. But we see FacadeX as a very important part in this ELT approach. FacadeX helps us with the E and the L mostly. And the total picture on how this looks like in TripDB is something like this. I hope you can see this, but this is what we call TripDB flows. It's a data flow that you can define. In this case, we have some imports XML from someplace, from a URL. And then, so that's the extract and the load part, the left part that you see here. And then there's a transform FacadeX, that's some query that go from one linked data representation to another. And then there's a final SECL validation step that is applied to make sure that things fit the correct description. And what you see here is, well, that's the ELT approach, what we call flows in TripDB.
Yeah,
I think this is where you come in, right?
exactly.
Yeah.
So I will talk to you a bit more about the load part and how FacadeX is applicable there, of course. And if you go to the so what components of FacadeX are important for this load part? Because as I understand FacadeX, there are 3 components to it. There's the data part, so in this case, a CSV. I hope you can see my mouse. And then there's a query part. So what would you write down in as a special service query, such that you can query this data, and then the RDF that comes out for this example query. I took these from the documentation page of CSV. But interestingly, for the ELT approach, so for this load part, we don't want to use the query part of FacadeX. The interesting part of the load part is how data in any non-RDF format is kind of inserted as RDF. So this data conversion definition, that is what is extremely useful for us. So the needs for such a data conversion are the following. I think this is a very dense slide. Yeah, it's mainly the glue. between the two. And what is important in these transformation flows is that we don't lose information, because if, like in this interface, there is little to no configuration you can do on this side. You really want all the configuration, all customization to be using RDF standards and no options or wizards or whatever. But this means that no data must be lost. Otherwise, yeah, it's impossible to do anything with the data. And similarly, so this is more of a usability one. Ideally, the schema of the RDF that comes out is easily queryable. It's a bit obvious, right? It's easy to use. And a bit in the same vein as the losslessness, the data should also not be interpreted, because we don't know yet what the intention of the data is, right? If the data format does not define something, we cannot assume anything. This must be applicable in any situation. So, for example, if you find this string in a CSV that looks suspiciously like a date, we should still nonetheless make sure it is actually string in the RDF data and not an actually date, because the CSV data format has no concepts of dates. It only has the concepts of text. And finally, what is important not only for Facade-X as a standard, but for almost all standards that we work with, is that there is very little space for implementation-dependent behavior, because when customers, when we want customers' expectations to be correct for our products, yeah, if there are lots of bells and whistles that are optional or not, and we decide to do some of them but not all, this can lead to a lot of friction. So it's important that the standard says exactly what to expect. And I think this is it, but I cannot see your nonverbal reaction. So I'm very curious as to what you think of this.
Thank you so much. No, this is really interesting and certainly very helpful. I have a couple of observations and questions, but I want to first give space to the audience if there is anybody else in the group that want to respond. Unless I'll start. So I think that this is really interesting. First, I have a comment on the ELT approach. I think there is a pattern in what we hear from the various people from the industry, like the people that work with knowledge graphs and data integration, and it seems like to be emerge every time. There is a kind of paradigm shift that they bring. No, so they want to. So this idea of leaving. Doing the lifting first, translation first, and then leave for the rest. The transformation part is a recurrent theme, and this I think is a very important one. It's extremely important one because first of all, knowledge graph practitioners are not necessarily and not always developers. So the kind of the knowledge graph manipulation sometimes is part of the skill set of domain experts and not software engineers or developers. So the least the toolkit required, the better. And second, because this brings a lot of space for semantic web languages to be used more and more, including I think for example Shackle and the Sparkle rules. I think that they are cooking this in the new set of standards. So I think this is really cool. So this is just a comment, but maybe you can say something about this with respect to one of your like customers or use cases. One thing that I'm thinking of, for example, you have like what kind of issues you have with this approach with your use case. I'm thinking about if you have a very large CSV, you have like, I don't know, you have an Hadoop cluster with tons of very large tabular data, no? And I don't know whether, or there is a huge, I don't know, diversity of formats. No, many of them we don't know yet whether or how can we represent them. So what are kind of the limits, I will say, to this approach? Where does this hits a wall? If it does.
No. So I think the limits are mostly on the user experience part. I think it is. So personally, I find the representation charming, using RDF collection and such. But bridging the so we've seen users trying to make queries such as give me so extract the value of the last column in a CSV, or get the so iterating over items in a CSV where each row should be considered a record except for the very first one, adding lots of filter not exists and stuff. So it's very easy creating a query that is quite complicated.
I see. Yeah.
And I think that's something that we're struggling with, especially because we're competing against so for typical simple CSVs with just one single line of header, and then every line is a record below, right? Then a lot more easier representations, record representations for these particular CSVs than Facade provides, right? So it's also
I think this makes a lot of sense. So I think there are two elements here. One is like query support. So when we should, after like dedicating ourselves to the specifications of the formats and the translation, we should also focus on query support. So what could we suggest to extend, for example, to extend Sparkle to make it easier to query FacadX resources? And then the second part is, the second comment that I have is that there is a kind of trade-off between simplicity of the translation and the lossless part. So for example, if you want to keep a sense of the order of the rows in a CSV, which in many cases is not relevant, but not all of it, you can know, like in the date example Martin was making, then we need this first to represent this as part of the facade. Another case we had with a long discussion from another use case on XML. XML is known to be the hardest less intuitive way of listen to this facade translation, because so if you are not familiar with that, we use the element tag name as the type, as an RDF type, and then we use container membership property to connect each element to their children, and then named properties for the attributes. Okay, so that's kind of the ingredients of the translation. And the result is a very, very verbose graph. And sometimes people say, well, why don't you use elements for, but sometimes in many cases, elements and tags are used as properties in the the conceptual model of the XML. But this varies because of the application, right? So the only way we can preserve both order and semantics at meta model level is to project tags on RDF types, and so we can do that lossless transformation. But in many cases, that's not useful. So in many cases, since sometimes people want to have an easier way to query the XML rather than a lossless transformation. So I think there are borderline cases.
Yeah, I think internally we're probably leaning towards something like SECL Sparkle functions to help our users with this. I think so. This is something we have to build from scratch, like a collection of SECL Sparkle functions to deal with particular facade representations in the context of CSV or XML or something similar. And I think that's
That's really interesting, and actually, maybe we should keep having this like conversations, and also maybe look at what we did with the Sparkle Anything set of functions. There's quite a lot. We implemented many functions, for example, to work with container membership properties, and to work with the sequence, like we have the next, the previous, so you can quickly relate members in the list. It would be cool if we could kind of collect all these functions and maybe normalize them in a specification as part of the work of the group.
Yeah, definitely.
Cool.
Yeah, that will be very useful, because the reason that we use SHACL Sparkle functions as opposed to custom functions is because it is a kind of a standard way to make a custom function. If we would say, yeah, we have very useful Sparkle functions to modify the FacadeX conversion, but they are in a tripling namespace, and if you change the product, then you can't use them anymore. Clients will say, okay, well, thank you very much. I won't use them because I want to be able to change the products. But if it's a standardized one that comes with Facade's standard, yeah.
Absolutely. No, even if it's a catalog of ways to implement those functions in SHACL, for example, that will be absolutely valuable to the community.
Yeah, thank you very much for your presentation. I have a question about formats. Since you deal with clients and also use cases, have you found any format not yet supported by the meta model? Is something that you would like to query via the FacadeX model, but it's not yet covered?
By heart, our tabular databases like supported, like
SQL and such.
yeah, SQL
SQL databases. Okay. Yeah.
Especially because some formats are reasonably easy because they like CSV is the easiest one because there's just very little variation. It's a very simple format, and then XML is hard in its hierarchy, but it's still only strings, or there's the C data, so there's 2 data types. Okay, and then JSON is already a bit more complicated because it has 2 or 3 data types, which is more than 1, which is already complicated. And then when you go to the data types that have more inherent data types, so the data structures that have more inherent data types, it would be extremely useful if there is a standard for that, because hand rolling it ourselves, right? Making these choices ourselves, how to do this mapping, that is just extremely hard. Yeah.
Yeah.
Yeah, noted that this is one of the things, relational database is one of the things that we haven't really explored in depth. We only have done it like theoretically in a paper, but never in practice. One thing on data types, I think, it brings me to another question I want to make you. There's a general one, and I want to make a general one and the same one about the more specific. The general one is what kind of specifications you think are needed. So for example, clearly we expect to produce an RDF vocabulary for FacadeX, and we are producing like a meta model specification, so a specification of the FacadeX conceptual model independently from the language or the RDF serialization. And then we plan to produce specification for each one of the formats that we know. We have addressed already, for example, with Sparkle Anything or with the research. But there, for example, we don't know yet, we haven't decided yet how to represent these mappings. Because we know, for example, that we can't do RML to represent like the meta model of objects. We could use description logic as like, but clearly, depending on the source format, we want to refer to a specification sometimes, and these specifications arrive in very different ways. No? like JSON spec is one. CSV, I don't know if there is an official RFC or for that, and all the various flavors. Like you have like the Excel version or and for XML is easy. We have a W3C spec. But again, what do we refer to when we encode the mapping? When we say, for example, look, this becomes a type. Look, this becomes an arc, a slot. This becomes a slot number. This becomes a slot string. And look, this will be the data type of this literal. Okay. I don't know if you have ideas on that, on any of this.
So you're asking about a way to express the meta model?
Yes, one is what kind of specification, what kind of documents would you expect to see from this working group when we arrive at September, hopefully, or the autumn more credibly, with the first set of specifications? What kind of documents you expect to see? And then, yes, I think we are a bit in a reflecting on how to encode these mappings in a way that is formal, but at the same time intuitive and readable, so that if anybody wants to engineer this transformation, can read the document and do it easily.
I think
also, this is for everyone as well.
Yeah.
We have our guests.
I think reading different standards, defining a new formal system is often a lot of overhead to try to get into a spec. And it's really great if you could like I don't know, reuse RDF as is, or I don't know, eBNF is always reused, right, throughout specs. I don't think it applies here, but tests are also extremely useful especially when it comes to paired data conversions, saying these things should be these things. Not necessarily a test suite, but just yeah.
A by example presentation, you mean, so that
Yes.
every concept is presented with an example or one or more examples of how the transformation would look like. Yeah, that makes a lot of sense. Because clearly developers can pick up that much more easily than going through a complex like formalization. Totally agree.
Yeah.
Makes a lot of sense. Thanks.
And another question, since one of the controversies was mentioned before is, I mean, nothing, no information is lost in the transformation, but it's maybe sometimes hard to see where a value is then placed in the RDF graph. Okay, and in order to start querying FacadeX RDF, a good practice, which I usually also do, is start with an NSPO query, and then start querying all the slots and get what kind of values you can find in a slot, and then you try to come up with the sort of map of the graph, and then start query write the queries that you want to put maybe in your process. And so one controversy is it's hard sometimes to get there to have a clear picture of what you can, of the structure of the graph and the values that you find in the graph and where these values are placed. So can you tell us, I just want to ask you if you have any common practice to start querying FacadeX graphs, and your a comment on how it's hard to starting query this kind of graphs that are automatically produced.
Yes, I think I think this is a problem that's to a large extent is unrelated to Facade X. I think the person who uploads something, whether it's an XML or CSV, often has a very resource-centric picture on the data that is uploaded. It can be, I don't know, an XML file, and the XML file contains persons, and then that user knows exactly what properties and which tags and attributes are used inside the XML to describe that person. And I think what helps that user understanding the linked data representation is having the same resource-centric equivalent, but then represented in linked data. So, for instance, a SPARQL query that fetches the very first resource, the very first person from the data you just uploaded. But then in Facade X, right? I think something like that maps with the user's understanding of the structure. So that's the direction that we're seeing here, because it's via the SPARQL query, you also communicate how the linked data structure of that particular resource looks like.
You're saying automatically generate an example SPARQL query.
Something like
Right?
that. Yeah. Thanks for the clarification. Yeah. So that's something that that we're thinking about. But to be honest, the world is very much in flux. So things like this may change with better usage of LLMs and stuff. Maybe this is a problem that simply will be reduced automatically simply by having better systems that generate these queries for you. And then it's
that could
it's
be
a
a
non-issue.
solution.
Yeah.
That's everything today. Solved by LLM.
Yes, and by the way, they're also quite good, also with Facade X resources. I mean, I've done a few experiments like with Claude, and really, the SPARQL queries generated, even with the old Facade X, the SPARQL anything properties and everything, they're quite accurate. It's very impressive.
Yeah, exactly.
Yeah. By the way, I've tried as an exercise to come up because as in general, what I would like to get, since we have this uniform model for everything, my idea was to try to come up with a single query to have a view over everything you have materialized in the Facade X graph, and I came up with a general query for having such a view, just to what kind of containers do you have in the knowledge graph, and what are the slots of this knowledge graph. And my idea was to use this kind of queries for a visualization tool, for example, that allows you to explore a little bit the graph, and then so can provide you this overview of the RDF before querying. And if you are interested, there is a tutorial on this on the SPARQL anything repository.
Oh, definitely. Yeah, I'm interested. Yes.
Yeah, because clearly exploring is one of the things that we claimed originally, so the fact that this approach allows exploratory queries. So you don't need to know everything to encode the mapping. You just can start looking at the data and then incrementally build your SPARQL transformation.
Yeah.
So yes. Another aspect is on URIs versus blank nodes. Okay, so I'm opening this this topic because one of the questions I ask myself is: do we need a spec on how we mint URIs or not? On the one hand, it is immaterial for the Facade X, so you can generate blank nodes for. I'm speaking about individuals, so containers mainly, not types and properties for which we use either a standard fixed namespace, or we reuse the namespace of the XML if there is any, but we don't have this problem. But on, for example, with Spark or anything, now we allow to generate container URIs, and there is almost coherent, but not exactly perfect, consistent way for each format to generate a deterministic URI. And in many cases, this doesn't make sense. This doesn't make any difference. Also, it may be have some detrimental effect because you generate larger files, clearly, because you have for the larger RDF files. But in some cases, I could, for example, write queries very quickly because the way the URI was generated could allow me to synthesize somehow what was the container I was pointing at. Okay, so it kind of can make sense in some cases. I wonder whether you had any of us ever experience on this, or as reflected on. So is it useful to also specify how FACADEX system means URIs?
I think it is extremely useful. One of the so in the ETL approach, I also have to think about exactly what order I said letters, but the old way, deciding on the name of a node in the graph is actually a very hard problem, and something not immediately obvious from a transformation you're doing, also because it decides on the identity, right? If two things are the same or not, then especially if you have multi-file resources, then you want to choose a name such that the same resource has the same name, blah, blah, blah. And I think blank nodes are a really awful hack around, oh yeah, I don't want to have to think about this right now. But you must think about this at some point, because after uploading, this data is published, right? It has an identity. You need a name for it. So having a standardized naming scheme that works, right? That would be great.
No, this is good feedback. This is good feedback. I mean, just to be specific on Spark or anything, what we mostly do, we start from the locator of the resource, and then we start to append paths depending on where the container is in the depth of the resource, right? And when there is a slot string, we use the slot string that connects the following container as a path. And if there is a slot number, we use the number, the cardinal number, so that in the end we end up with a deterministic path. So this is not, I think, not exactly consistent for all the FACADEX transformers we have so far, but I don't remember exactly what the reason is. But I bet it can be like normalized, and it can become a specification, a part of the suite of specifications we produce. Martin.
Yeah, I suddenly realized what is important though is that the IRIs must not collide between files. So, for example, with CSV, the one way to make an IRI within a CSV is taking the X and Y coordinates, and okay, that's unique within a CSV. But if you upload multiple files, you don't want those different files to generate the same IRIs. So there must be some way to be a bit deterministic within a file, but also
usually
really deterministic across files.
Yeah, if the file has a locator like a URL, then usually that could be the starting point. But clearly this depends on the connector. Like you have, I don't know, you connect to usually you do have a URI, even if it's a file system URI or a REST3, even a JDBC connection is a URI. So we may easily build on that. I have another discussion topic, but if anybody wants to add anything on this, URIs and blank nodes. It's incredible how often we use URIs to mean things, and that's because those are kind of like talking URIs is something that has never been exactly specified how these URIs should talk. There are patterns, of course. You can mint URIs in different styles, but this is the fact that you can give semantics to URIs.
There is a lot of information inside the URIs that
Exactly,
you can exploit for classifying things, and that's incredible how much information we fit in a small string of text. Yeah.
Now, I was thinking about versioning, for example. You may have like even a fashion of doing this where you triplify a source file that is updated at a given location, and every time you triplify it, you have like a hash of the timestamp, no? That builds the container's IRIs. In this way, you always encode the full information. You have all the versions. And the other aspect is the graphs. We haven't talked about graph names yet, but usually, for example, in Sparkle Anything, and this is also part of the specification we are building, graph names are the way the data in resources is partitioned. Okay, so each resource is kind of an RDF data set. In most cases, you always have one graph, and but sometimes you may have more than one graph in a resource. Right? We make the example of the Excel spreadsheet, but I think one thing we should discuss probably more carefully in this community group is whether what's the role of named graphs in all this, because I'm not entirely convinced that the way we do it with Sparkle Anything is the best one. Okay, I wanted to go back on the how do we specify mappings for a second, okay, so that we can use this last part of the meeting to gather more more knowledge and to use your brains a bit more. So one of the thing I was thinking is that in most cases, apart from like relational database that we haven't touched yet, but we are talking about files, okay, so file formats, and the files will typically are parsed, so we have parsers. And typically parsers are specified with BNF grammars. So I wonder whether one way to have like a formal tool to express these things is to annotate BNF grammars. So we have like this kind of map of tokens and joins between tokens, and we can say, okay, this token is a slot, this other token is a type, this other token is data. Look, if this token is like this, then the data type is that. If this token is this other one, and so forth. Maybe that could be something to work with that is more consistent across formats.
And you see, you're describing this as a mechanism for communicating the.
Yeah, I'm talking about like when we publish the specification, there will be like clearly an overview spec, and there will be like the RDF vocabulary, the FX meta model, and then the list of mappings that we have explored. Right? So how do you map the CSV? How do you map? And clearly there will be like modifiers. You want to concede headers. They are the headers in the first row. These kind of things. But still, like before starting doing that, we are asking ourselves, okay, but what do we put in this? Apart from the examples, okay, you do this way, which probably will be the part that will be more useful. I agree, but still we want to formalize these things in a way that is kind of robust, because examples may go like for the common cases, but may not cover all cases.
I mean, I like the idea of reusing the grammars because it's well known. It's not, it's an existing formalization, and you can just piggyback off of it, and also make sure that you don't forget any edge cases with it. I think if you,
that's my main concern because we want these specifications to look rigorous. Also because we will submit this to W3C. So we want to do the best we can.
I'm not sure that terminal non-terminal elements of a grammar match one-on-one with the RDF node. Maybe you could have. You have to check. You have to check format by format if every non-terminal term in a RDF, which basically is the logic term, which is for example for a value for something. If this maps one-on-one with an RDF term, in that case we could formalize the map, maybe also logically, mathematically, in a sense. Even I think also with formal grammars, I suppose.
The good thing, sorry, Luigi.
Yeah.
The good thing is that BNF grammars are expected to generate streams on nodes. So maybe we can use that to say, okay, when we map the various tokens, we can express rules like if this token comes after or before this, then it is a slot and it is a number. And then you take the content or the next data part, like as to mint the URI. So maybe we can have this kind of direct relationship between the BNF tokens and the way triples are spit out, which also, by the way, would mean that we can generate parsers in any language.
Yeah.
Just from the specification.
Yeah.
In principle.
Yeah.
In a deterministic way, which would be, I think, some contribution.
Yeah, that would be cool. Yeah. Yeah, we have to try with a couple of BNF grammars. I tried for one of the first papers which introduced the theory, and was not so simple to make this map. Okay, but let's try again.
No, that's not. No, I remember that there was the limit is that you need to decide at some point whether you want something to become a relation or a container. I think that was you could not determine that from the actual grammar. But this is fine because what we are doing is that we design mappings, so we will make decisions about what goes where. I think the important thing is that once we make a decision, then we want this to be deterministically expressed in a way that is formally robust and unique.
Yes.
This has been a really useful session today, at least for me.
Yeah, no, a lot of feedback from users and also engineers. Yeah.
Martini, you should help us writing these specs at some point, because we need support, especially when we go specifying the various mappings. So any help is welcome. So keep coming to the meetings and help us building this. By the way, just informally tell everybody that Luigi and I want to submit a tutorial proposal for the next ISWC conference, because I think the work is mature enough to kind of like start showing, do a bit of showcase, a show and tell. So if anybody wants to join or help, is in Bari in November. It may not be accepted, but we will submit it. We want to submit it. I think the deadline is early July, Luigi.
Yeah. I'm checking. Let me see.
So
Important
if
dates.
any of you wants to participate, contribute?
And so I think, so personally, I'm the wrong person here. I'm really happy that I'm not writing papers anymore, to be honest. But put this on a mail also to me and Wouter.
Sure.
Maybe
Yeah,
Wouter.
I think I'll mail you, and then we'll take it from there. Of
Sure.
course.
Yeah, cool.
Deadline is June 9.
June 9. Okay, June 9. Yeah, but we have enough time. And also, I mean, mainly I'm asking also the Matthias, Ivo, and the others here in the group. So maybe we'll have a conversation on emails on this. Okay, I think looks like we have finished.
Thanks a lot for having us.
Yeah.
So next meeting, when is it, Luigi?
June.
12.
Yeah, maybe.
20. No, because we pushed it because of the first week of June. I'm away.
Let me see. June 15.
June 15. Okay. So you're always very welcome. We will not have, I think, presentations, and I think we want to have one session with presenters and one when we actually do the work on the specs, because last few months been busy with hearing from industry practitioners, and we had done a bit little discussion about the actual specs. But I think we need both, so we'll keep to have this kind of dual format. And we'll send at some point minutes of this meeting, and we'll publish the recordings as well. So thank you all very much for your contributions. It's been very, very, very useful. And happy Star Wars Day.
May the force be with you.
Force with you. And bye-bye.
See you
See you
later.
next time. Thanks so much.
Thank
Thanks,
you.
Lawrence. Thanks, Martin.
Thank you.
Thanks,
Bye.
everyone.
Thanks.
Bye-bye.
Bye.